All this is Dr. Mobeen Sayed from drbeen.com. Welcome to one more show. So today this is Dr. Mobeen Sayed with Kairi here, and she is right over here. Luffy is already outside. So the discussion today I want to do is the discovery of ivermectin and then the Nobel Prize of it. It is a fascinating story, and as nowadays this poor drug has been bad mouthed a lot, I wanted to make sure that we can at least understand what is the origin and see that story together. Um, I can only f- I can only feel for the inventors and discoverers how they might be feeling. So let's look at the story of ivermectin. If Kyrie lets me talk, she's pulling on my sweater from here. So let's start. So this is the Nobel Prize site. In here, this is 2015 Nobel Prize in Physiology or Medicine. And in this one, there is the story of the ivermectin for parasitic, anti-parasitic, as in anti-parasitic drug, or for worms, and not horses only, but humans as well. So I'm going to go uh, through the story of the discovery. This is not really about the efficacy of it, the actions of it. We have done those discussions a lot. This is about the story of the discovery. Now, in addition to this, some more links. This is CDC about the use of ivermectin, which is for the river blindness and um, elephantiasis. These are the references to various pathogens that are involved in these diseases against which ivermectin helps. And so, again, from the Nobel Prize point of view, ivermectin has been known to do many more things. But when the Nobel Prize was given, what was it given for? I wanted to see that with us. And then these Streptomyces bacteria, soil bacteria, the bacteria to which we all have to be grateful. These are these bacteria. These bacteria have given us two Nobel Prize winning substances or substrates or things, molecules. One is the streptomycin, and discovery of that got a Nobel Prize as well. And the other one is the ivermectin, which also got the Nobel Prize. And the little poor microscopic things that produce them are called streptomyces. And of course, we are indebted to these. So here is the story. If you are on the East Coast, you would actually enjoy it more. This is cold. You are tucked in your bed, and we are going to go through the bedtime story of ivermectin discovery. So here, so in 2015, the Nobel Prize for Physiology or Medicine, and again, please don't send me this comment that why am I saying physiology, or I should say, and this is how it is, physiology or medicine 2015. This Nobel Prize was granted to two molecules. One of them was for the um, ivermectin, and the other one was the therapy for malaria. So there were two separate Nobel Prizes divided into these two groups. Check out my diagrams. So this is William C. Campbell. William C. Campbell was an American, is an American. Satoshi Omura is Japanese origin but American. They are the two partners who found it. And again, the story is fascinating that how did they found this? And I think my diagrams illustrations are hopefully okay as well. So continuing. So what is the why did they get the Nobel Prize for discovering this molecule? The reason for that was that there are two diseases that had been very prevalent in South Asia, in Sub Saharan Africa, and many other impoverished countries. And these two diseases were one of them was Elephantiasis or scrotal hydrocele or filariasis. What that does is that in this disease, there is a worm that sits down in the lymphatic channels of a human being, And when the worm sits down and occupies the lymphatic channel's function is to clear the debris or bigger molecules from our tissues back towards the heart. So imagine if the blood vascular system is very tightly controlled for what enters it, then we have a problem. The problem is in the tissues, in the tissue spaces, there are broken cells sometimes, there are pathogens sometimes, there is debris, there is trash. How do we clear and clean that trash out? That trash is cleaned out through a bigger channel or set of channels called lymphatics. Lymphatics can get the bigger debris or trash. You can think of that as a river which is polluted with lots of junk. That all goes to lymph nodes. Lymph nodes then see what kind of antigens and pathogens are coming their way. They start attacking them to clear the trash wherever the infections may be, and then the cleaned up fluids go back to the cardiovascular system. If you block these channels, if these ravines that have trash in them and they are clearing the trash away, this is like sewer system for our homes. If that sewer system is blocked, then what would happen is that the sewer would overfill. So that is what happens here. This little worm, it reaches a human being through a mosquito. So a mosquito bites one human being who may have this worm, then the small worms or the eggs or whatever baby worms, they are taken up by the mosquito. Again, this is not a life cycle discussion. This is more of a what diseases ivermectin helps. And then mosquito goes and bites another human being and infects them with the uh, Ben crofty. So there are three kinds of worms that can do this. Most common in them is called Ben crofty. This Ben crofty worm would come in and sit down in the lymphatic channels and obstruct them. Imagine obstructing the sewer systems. And now what happens is the fluid that need to be cleared out of lower limb, legs, scrotum, they do not clear out correctly. This also tells you the importance of lymphatics. It's not only the blood vascular system that brings the blood and fluid back to the heart. The lymphatic system is paramount and a very important system of channels that bring in tons of fluid back towards heart. And tons I'm using as as an expression, not actual volume. So if you block lymphatic channels, the limbs, the parts of the body where the gravitation is occurring, those get filled with fluids and that fluid does not go back. That causes elephantiasis. And if it happens to scrotum, the scrotums become really, really swollen up as well. Ivermectin helps against that. And if we look at the Nobel Prize site, which I'll see that in a second with you, they say that these diseases are almost eliminated because of the discovery of ivermectin. And they say that 3.5 billion people, or more than 1/3 of the world population, lives at risk of these worms, which is protected by ivermectin. What a beautiful thing. And I can only imagine the discoverers and their feeling when they found out how much they have helped humanity. We sit here and complain about each other and think we have done something. Here are the people who have helped humanity. So here is the second disease. The second disease, if you see here, this is an eyeball. This eyeball is crying. Why is it crying? Because inside the eyeball, there are worms. So again, what happens is this worm is Onchocercia or Onchocercia. Some pronounce it that way, some this way. I have heard other pronunciations too. So whatever floats your boat, Onchocercia or Onchocercia volvulus, this is a worm, another worm. This worm spreads through black flies bite. So black fly picks it up from one person, then bites another person, brings it to that person. Usually it causes lots of skin infections and skin irritation and skin infection, but it can actually enter the eye, and then it can infect and damage cornea of the eye, the looking part of the eye, and that eventually causes blindness. This is also called river blindness or onchocerciasis, river blindness, because this, in some countries, there are outhouses. The toilets are built on top of rivers, and when people go use the outhouses, the fecal matter can have these worms in them, and downstream, if there are people who are using that water or they are bathing in that water, they can also get infected, and so that is why it is also called river blindness. So these are the two important diseases. So let's look at the site here. So William C. Campbell and Satoshi Omura, for their discoveries concerning a novel therapy against infections caused by roundworm parasites, they discovered a new drug, Avermectin. They originally named it Avermectin, and I'll go to that in a second. And they said that, and its derivative, of which have radically lowered the incidence of river blindness and lymphatic filariasis, as well as showing efficacy against an expanding number of other parasitic diseases. And now we know that it is showing efficacy for many other things as well. So here they continue to talk about these diseases. I have just presented them to you. Now, how did they discover it? That is a beautiful story. So let's now see how did they discover this. So here is what happened. Satoshi Omura, which has very recently given some statements about ivermectin and its efficacy as well. Satoshi Omura is an expert in soil bacteria, especially Streptomyces. So in the soil live Streptomyces. Streptomyces, normally these bacteria normally help decompose things that are in the soil. In addition to that, it was found that Streptomyces make streptomycin, for example, which is a very, very useful drug. And for that discovery, there was a Nobel Prize given. So Satoshi Omura, I hope I'm pronouncing his name correctly, he used to collect soil samples, and from those samples he would culture these bacteria. Then he would try to use those bacteria and see if they can be effective against something else. So this is really you and me picking up a bunch of soil, putting that in some culture medium, growing bacteria from that soil, and then using those bacteria in other infections and seeing if they can kill them or they can make some molecule that can kill them. This is how Satoshi Omura used to do his research. So if you see here on the Nobel Prize site, they depict that as this, that these are the soil samples, these are the cultures. In the cultures, there are Streptomyces. So here in those cultures, these are Streptomyces. So Satoshi Omura created a new set of cultures, and there were, of course, new Streptomyces strains in there. So one of the strain was the one that was going to become the parent of ivermectin. Now, how did that happen? So Satoshi Omura had thousands of samples, soil samples, and he used to keep them and nurture them and observe them and select the ones that may have been effective against some other infections. So he had shortlisted 50 soil samples, which to him seemed more promising in possibly having some useful molecule in them compared to other thousands of them. Imagine that person's work. Imagine the keyboard warriors nowadays, and imagine the people who are actually helping humanity in producing work. So he would collect the samples, thousands of them, Then he would test what culture from there can be of what benefit. From there, he had shortlisted 50. Now, William C. Campbell in the US requested the soil samples. And out of those 50 soil samples, William found one soil sample, and that culture of from that one soil sample, and the culture was producing something that was killing the worms. And why did he started looking at the worms? Because William's work has been for parasites. So very interesting. One scientist, researcher, his whole life was around soil samples and the bacteria and how do they can they be of any use to us. Continuous Imagine you continuously picking up soil samples and culturing them and seeing can they be of some use. And then William, his job was he would continue to find molecules that may kill parasites. Imagine his mindset. He's always thinking, can I find some molecule somewhere that can kill a parasite? I am so glad that we did not tell him that you need to have some sort of an RCT before you try to figure out if you can kill something or not. But he would keep looking at those. And he found one of the soil sample was dangerous and deadly for worms. So of course, then they started working on figuring out what the heck is in that sample, what is in that culture, what are these specific strains of Streptomyces, what are they making? And they found out the molecule that was doing it, and they called that molecule Avermectin. So that was the parent molecule or the organic molecule that they found. So this here on the top is the molecule that is Avermectin. Then what they did was they took that molecule and they further modified it. So if you see here in this lower diagram, there is this orange little thing. That is the only tiny modification they did. And with that modification, the efficacy of Avermectin increased. Now they called it Ivermectin. So this over here stands for Ivermectin. So they modified it, made it more effective, called it Ivermectin. That Ivermectin then first was, of course, tested on animals, and it worked very well to deworm the animals. Then they tested it on humans, and they found it to be safe and effective on humans as well. And then, if you see here, when I read this one sentence here, I wish I can get to it quickly. Look at this. Today, the Avermectin derivative, Ivermectin, is used in all parts of the world that are plagued by parasitic diseases. Ivermectin is highly effective against a range of parasites, has limited side effects, and is freely available across the globe. Treatment is so successful that these diseases are on the verge of eradication, which would be a major feat in the medical history of humankind. So they tested it in humans, they found it to be really safe, and now it is available in billions of doses worldwide, given in billions of doses worldwide, eradicating these deadly diseases, and is a hero. So, in addition to these researchers, I think that the the bacteria that should get a Nobel Prize is also Streptomyces. Streptomyces helped give us streptomycin, plus they gave us ivermectin as well. So this is the study of the history or the discovery of ivermectin. I hope you liked it. I thought it would be a nice, cute story that we can tell and we can understand more about it instead of There are folks who badmouth it, there are folks who like it, and I think whoever we are, knowing it a little deeper is very useful. So, with this, thank you very much for your time. Please, if you like to support this work, there are 3 links in the description. You can buy me a coffee, or you can support through PayPal, or you can be a patron. Thank you very much, and I would see you shortly for a little chit chat as well. And you can help by liking and subscribing as well.